George Washington. You may know him as the first president of the United States, or one of the most revered generals who brought the 13 colonies together to make our home we call the United States. But today, he's the guy who we, fired up casting, are making a sword for. And here's our process and final results. The team was tasked to research, design, cast, and test a single-edged sword that Washington would use based off his known preferences and needs, along with providing the mechanical properties and quality comparable to forging. Our team starts off strong by creating a timeline so that we'd efficiently see the success of our project. The team created multiple concept handle sketches along with 6 concept blade designs based on George Washington's known preferences. After doing research, our group decided that the 4300 series steels would be the best option for our blade that is going to be sandcasted due to its high strength and toughness, and that for our handle, which is going to be investment casted in-house, pewter would be the best option due to its resemblance to silver, along with its ease of manufacturing and casting ourselves. After several concept designs went under a scoring matrix process, a design similar to Washington's Bailey Coteau was selected for our handle and blade. Lastly, for our sword assembly, the handle components will be attached to the blade using JB Weld epoxy. After selecting our designs, the team created CAD models for both our sword and universal handle components, which include our guard, pommel caps, and wooden handle. Our blade would then be tested using static FEA analysis on edge retention. After doing research and modeling, the team decided on these iterations for the mold design. The handle components will be made of pewter, a metal with a relatively low melting point, but also would have the benefit of its weight and tensile strength. But before we pour, we need to prep. The team's prep process for the handle components include using 3D printing polycast burnout filament parts, dipping those parts in a ceramic slurry mixture, prepping and drilling holes to open gates and risers, then burning out said filaments, and finally pouring our melted pewter until the risers fill, then cracking open the ceramic parts to see the results of our unpolished casted parts. Lastly, for our handle components, the group decided to CNC a hickory wood handle, then staining it a cherry color, paying homage to the legend of George Washington receiving a hatchet and damaging his father's cherry tree. After all said and done, we have our finished handle parts. Now the team begins the blade manufacturing process. We start this stage of the project beginning with prepping the 3D printed sand mold by first cleaning and putting a coat that creates a barrier between the sand mold and molten metal. After that, the group starts assembling the mold, packing sand, and drilling holes for venting. And then finally, using Baycast's 3,500 pound ladle, the team pours a 4-pound casting, and after extreme difficulty and precision, we failed and learned. Now, after repeating the process again and changing our material selection and part design, the attempt failed. But even with these obstacles, our team refuses to give up. So we did what all engineers do. We panicked. Just kidding. We attempted to problem solve. In the problem solving stage, we put our heads together and came up with a prototype we called George Washington's butter knife. After changing the gating system, slightly editing CAD designs, and looking at our material selection, our team had one last try. So we repeated the process again, and the team got blades, 3 to be exact. After this small but essential win, the group begins our after casting stage by using GD&T drafts to grind down our blades to be within tolerance of our dimensions. After this stage, the team took our blades back to Baycast so we can start our heat treatment process and annealing, along with doing some ultrasonic testing. The team then lastly added our finishing touches with sharpening and assembling our blade, and then sent it off after some quick testing. We hope you enjoyed our video. Thanks for watching.